Good morning, scholars. Today we're going to begin our lesson with a do now. Solve both of these problems, enter your answers, and then we'll review. So the first problem, I see I have a Ferris wheel that has a radius of 65. I'm going to go ahead and underline radius because I know that is a key word. I want to know the distance that a person travels in 3 full rotations. So I'm going to draw a picture of a Ferris wheel, which I know is a circle. If I have a person sitting on the outside, they're traveling around the Ferris wheel. So right now I know that I'm going to be using the circumference formula of a circle since we're talking about the outside. So I'm going to write my formula C equals 2 pi r. The problem said I have a radius of 65 feet, so I'm going to label this radius 65. Remember, a radius goes from the center of the circle to the outside. And then it's asking for how many times, or the distance for 3 full rotations, which means this person travels once, then he travels twice, then he travels a third time. So I'm going to first need to find the circumference. So 2 times 3.14 for pi times my radius 65, and I get C equals 408.2 feet. He travels in one time around, since that's the circumference of the Ferris wheel. But we know he went 3 times around, so I need to now multiply this number by 3, and I get 1,224.6 feet. As always, make sure you correct any mistakes that you made. Alright, the second one, I forgot to say we should not have used our calculator to solve number 2. This is going to be on the inactive part of the test. So the question is asking for his unit rate in miles per hour. So this is going back to a unit rate problem. This is a comparison, so I can write a ratio. I'm comparing miles to the hours. Now I can go ahead and fill in my numbers. I already know that he does 1/3 of a mile, and it takes him 1/9 of an hour to run that. So in order to solve, I'm just going to divide 1/3 divided by, that's what this line means, 1/9. To divide fractions, I keep, change to multiplication, flip, multiply straight across, we get 9/3, and 9 divided by 3 is just 3. So he runs 3 miles per hour. Now it's time for our ASMD with fractions that we're going to do every Tuesday. So take a minute, solve each one of these 4 fraction operations without a calculator. Again, these are going to be seen on the inactive part. We need to begin and continue practicing operating with fractions without a calculator. So work these out, enter your answers, and then we'll go over them. So number 1, we are adding fractions. In order to add fractions, we must have a common denominator. So if I have 5 and 10, I can make that 5 become 10 by multiplying by 2, which means if I multiply the denominator by 2, I have to multiply the numerator by 2. So this first fraction becomes 2 6/10 plus, I don't have to change the second fraction since its denominator is already 10. I add my whole numbers, 2 plus 4 is 6, Add my numerators. 6 plus 3 is 9. Denominator is 10. 6 and 9/10 cannot be simplified. So that is my final answer. Number 2, again, when I'm subtracting, I also need common denominators. I can make 2 become 4 by multiplying by 2, which means I also have to multiply the top by 2. So 8 and 3/4 can stay the same, minus 6 and now it's 2/4. Again, 1 times 2 is 2, 2 times 2 is 4. Then I subtract 8 minus 6 is 2. And then my numerators, 3 minus 2 is 1/4. So my final answer with that is 2 and 1/4. Multiplying fractions. Again, I always need to change any mixed numbers into an improper fraction. So this is going to be 1/6 times 3 times 3 is 9 plus 1 is 10 over 3 as an improper fraction. Multiply straight across, I get 10 over 18. I can simplify this though. Both the numerator and the denominator can be divided by 2. 10 divided by 2 is 5, and 18 divided by 2 is 9. So my final simplified answer is 5/9 for number 3. Alright, and my last one, dividing fractions again. Got to change the mixed number into an improper fraction. 2 times 2 is 4, plus 1 is 5. So I get 5 over 2 divided by whole numbers we need to put over 1. Dividing fractions, I keep, change, flip, multiply across, I get 5 over 12, and that cannot be simplified, so 5/12 is our final answer. Be sure before moving on that you have corrected any mistakes that you may have made. Alright, so yesterday we began talking about volume. So volume is the space inside of a three-dimensional object. So a three-dimensional object has a length, a width, and a height. Today you're going to spend most of the time practicing calculating the volume of different prisms. We're going to do a quick checkpoint to see and to review what we did yesterday. So this first shape I see is a triangular prism. Again, a prism gets its name from the shape of its base. A prism has two parallel bases. So this prism is a triangular prism. Its base is a triangle. It has two triangles. They are parallel to each other. They don't touch. So yesterday we learned there were two formulas for volume of a triangular prism. You use whatever you understand best. So the first one you could use, so volume of a triangular prism is the area of the base. So the area of a triangle is 1/2 base times height. And then we need to multiply it by the height of the whole 3D figure. You also, or you might like using this formula. So again, to find the area of the base, the area of a triangle, you do base times height divided by 2, and then still multiplied by the whole height of the 3D figure. So I'm going to go ahead and just start with this first way. So to find the area of the base, which is a triangle is 1/2 times the base of the triangle is 9, and the height of the triangle is 6. Remember, the base and the height of the triangle have to form that right angle. And then the height of the whole 3D figure is this 10 because it connects your two triangles. So in this parentheses, 1/2 times 9 times 6 is going to be 27. And then I'm going to multiply that by 10. So my volume is 270 cubic kilometers or kilometers cubed. To show you how the second formula works, if you would rather use that one, again, I'm going to use the base and the height of the triangle. So the base is 9 times the height, which is 6. We're going to divide that by 2. And we're going to multiply it by the whole height of the 3D figure, which is 10. 9 times 6 is 54. 54 divided by 2, still multiplied by 10. 54 divided by 2 is 27. So 27 times 10 is 270. So both formulas gave us the same answer of 270. You use whatever formula you see and understand best. Number 2, we have a cube. Remember, cube is just a prism whose faces are all squares. So all sides are the same length. So this is saying that this has a side length of 2.5. So that means if the length is 2.5, the width is 2.5, and the height is 2.5. All sides are equal. So find the volume of a cube is just length times width times height. So 2.5 times 2.5 times 2.5 is 15.625 inches cubed, or cubic inches. Again, volume is measured in cubic units, whereas area is measured in square units. All right, number 3, we have a rectangular prism. The base is a rectangle, and there would be another base down here. So same formula, volume equals length times width times height. The area of a rectangle is length times width, so then we just multiply it by our 3D height. So it's going to be 25 times 3 times 7. We get a total volume of 525 inches cubed. It is that easy if we know our formulas and we plug our numbers in. Now it's time for your practice. Go ahead and find the volume of rectangular prism number 1. So first thing we always want to do is write the formula. So V equals length times width times height for a rectangular prism. Fill in my numbers, 3 times 2 times 13, and I get the volume is 78 cubic inches. Find the volume of triangular prism number 2. Again, first things first, write my formula. I'm going to use base times height divided by 2 times height. Again, you can also use this formula and you should get the same answer. So the base of my triangle is 8 times the height of my triangle, which is 9. Again, they also have to form that right angle. I'm going to divide that by 2 since it's a triangle. And the height of the whole figure is 5. We would really have a triangle back here. So this 5 connects the front triangle with the back triangle. Go ahead and multiply it out. 8 times 9 is 72 over 2 times 5. So I get 36 times 5, and my volume comes out to be 180 cubic centimeters. Great job if you got these correct, and make sure before you move on that you correct any mistakes. Find the volume for triangular prism number 3. Always write your formula. Volume equals base times height divided by 2 times height, or your other formula. The base of the triangle is 8. The height of the triangle is 6. I'm going to divide that by 2. And the height of the whole figure is 15. Because this line connects your two bases. It connects your two triangles. So 8 times 6 is 48. Divided by 2 times 15. 48 divided by 2 is 24 times 15. We get 360 cubic centimeters. Go ahead and find the volume for number 4. So remember, if I have a cube, if the side length is 7, that means the length is 7, the width is 7, and the height is 7. So my volume is just going to be length times width times height. So it's going to be 7 times 7 times 7. So I get a volume of 343 cubic inches, or inches cubed. Find the volume of prism number 5. So 5 is a rectangular prism. Since its base is a rectangle, which means my formula is going to be length times width times height. So 20 times 8 times a height of 16. Multiply it all out, and we get a volume of 2,560 cubic centimeters. Find the volume of prism number 6. So number 6 is a triangular prism because my base is a triangle. So I'm going to set up my formula. Base times height divided by 2 times the 3D height. Again, if you're using this formula, that is completely fine. Plug in my numbers. The base of my triangle is 2 times the height of the triangle is 6. I have to divide that by 2. And the height of the whole 3D figure is 9 because it connects your front triangle with your back triangle. So it connects your two triangular bases. 2 times 6 is 12 over 2 times 9. 12 divided by 2 is 6 times 9, so we get a volume of 54 centimeters cubed. Great job if you got those correct. Again, before moving on, be sure you correct any mistakes. Read problem number 7 and use the prisms to help you solve. Enter your answer and then we'll review. So I see the problem says that the width of the rectangular prism is 5. So I'm going to first go ahead and label the width 5 since it's not already drawn in the picture. The question is asking for the difference. Automatically I'm going to know that I'm going to have to subtract something because difference means subtract between the volume of the rectangular prism and the triangular prism. Okay, so I'm just going to do one prism at a time. For my triangular prism, base times height divided by 2. again, always write your formula, times the height of the whole figure, the base of the triangle. This one is tricky. Remember we said the base and the height of a triangle always have to form a right angle, which means that the 6 and the 8 are the base and the height of the triangle because they form a right angle. If you notice, the 10, while it might look like it's on the bottom, it doesn't form a right angle, which means it cannot be the base or the height. So the 6 and the 8 are going to be the base and the height. Since it's a triangle, we need to divide that by 2, and 12 is the height of the whole figure. Be sure you correct this now if you had 10 as your base. So here I'm going to multiply in the parentheses. 6 times 8 is 48, divided by 2, times 12. 48 divided by 2 is 24. I'm going to multiply that by 12, and I get a volume of 288 units cubed. I left it as units because it didn't tell me specifically inches, centimeters, meters, anything like that. So this is the volume of the triangular prism. I also need to find the volume of the rectangular prism, which is just length times width times height, which is going to be 6 times 5 times 4, and I get 120 units cubed. My last step is to subtract in order to find the difference. So 288, my triangular prism is larger. Subtract 120, and I get a difference of 168 cubic units as the difference. Great job if you got that correct, and if you made this mistake right here, just be sure you have corrected it on your paper. Now it's time to show off what you have learned from your practice with solving for volume. Here is your exit ticket for the day. Solve for the volume of each of the 3 prisms and enter your answers into the computer. Great job today.